Okay, welcome to the, I guess, summary video for the investigation on end behavior. Now, before we go any farther, you do not watch this video until after you've done the investigation. Watch after you do the investigation. Okay? Purpose of that is so that you kind of go through this. It's very easy, it's straightforward. So, pause right there. If you haven't done that yet, go do the activity, do as much as you can, try to get through the end, and then hit play again on here. All right, I'm going to leave that. Now that that's said and done, we're going to start back up and talk about what you should have found. Real quickly, just to summarize, what should have happened here is that you're going to sketch. And hopefully I outlined this in class. I believe I will. Sketch means you don't need to worry about points or accuracy. We just want to see the general shape. Now, our goal for this activity is end behavior. So the only thing that we're really concerned about here is what's happening on the ends of the function. We know that it should end with two arrows going in some direction. That's all we're concerned about. We're not concerned about the middle. We'll actually do the middle tomorrow. We've already done a little bit of the middle with the intercept. So right now we're just focusing on what's going on left and right side after all the fun stuff in the middle takes place. So how this should have looked is you should have grabbed a Desmos calculator somewhere around here, and you should have slapped them in. Look, x cubed. I'll scroll over to the x cubed one here. Here it is, right here, x cubed. You would have typed in x cubed in Desmos, and you said, hey, look, the left side's going down, the right side's going up. Well, that's simple. It went through the origin. Whoop, you would have done a little graph there. You would have went doodle 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 doodle. That's it. Don't spend any time doing these. Hopefully you didn't. If you've watched this and you haven't done it, well, hey, there's a little tip for you. But I went over that in class. So now that you've got that part done, let's take a look at what you should have found from this. What you should find in this is that the end behavior has a pattern to it. Let's see if we can get to that pattern. You've already hopefully figured it out, so I won't spend too much time on it, but what you're going to find out is that if the leading degree, right, these are the degrees that we're looking at. If this leading degree is what we're looking at, if it's even, okay, and it's positive, meaning the value in, oops, we don't want that, we want the value in front, right? So these signs right here, there's a negative sign, this one doesn't have it, so it's positive. So if it's even and positive, both ends go up. So all we're concerned with this is that you have two arrows going up. They don't have to go sideways. You can quite literally do them both vertical. I really don't care. That just describes what's happening at the ends of the function. We're not concerned where the intercepts are. We're not concerned where the turning points are, and you'll find out more about that in a little bit. You're not concerned about that turning point or this turning point and that there's two zeros here. All you're concerned with is what is the arrows doing on the left side and the right side. So the pattern is, if it's even, they go the same direction. Same direction. That's what you should be getting from this, which is quite different from what you find if they're odd. If they're odd, they go opposite directions. Okay? Well, if it's positive, they both go up. I'm guessing you already know that, and if it's negative, it both goes down, because it's really easy to know that because we've done a lot with quadratics. But polynomials, all even-degreed polynomials, not just squares, do that. So any even degree, 6, 102, 2 million, whatever the degree is, if it's even, they go the same direction. If it's negative, it goes down. If it's positive, it goes up. Odd ones are different. The way I like to think of those is if it's positive, it should be an increasing function from left to right. And I just drew an increasing line, right? So from left to right, I'm going up. Well, look at what the end behavior is doing on this particular odd function here. It's down on the left, it's up on the right. Overall, if I go from left to right, it's increasing. So positive ones are going to go up, start low and high, if you will. And then so you're going to start low and high. Again, I don't care if they're vertical or sideways like these are. Odd's going to do the opposite of that. It's going to start high on the left and end low, meaning it's a overall decreasing function. So negative down, positive up, that's pretty easy to remember. Again, those are all odd. If we made this 9, if we made it 13, if we made it 15, doesn't matter the degree, all of them are going to end in the same way. The middles may look a little different, but that's not what we're concerned with. So how does this play into what we're doing? Well, these are pieces of how we're going to graph. You've got the intercepts down, you know the y-intercept, and now we're adding what's going on at the end of it. So we're putting all these little pieces together, the graph, basically any polynomial that you get, any degree of any squared variable or higher. So first things first, you got to take a look at the leading coefficient to do end behavior. Why? Because it tells you if it goes up or down, right? That was important. So first thing you want to look at, if you look at these first two examples, the leading coefficient's 3, this one's 4, they're both positive. Pretty straightforward. Now you're going to check the degree of it. This has a degree of 1, this has a degree of 3. These both happen to be odd. If they were a 2, like this one, we would write, let's actually do it. We would say even. Okay, oh, let's do our degree, our leading coefficient sign. So this one's going to be negative. All right, so now what's that mean about the end behavior? Well, you scroll back up here if you've forgotten, and you match to whatever one these are. So we're going to say odd and positive, they go down on the left, up on the right. Remember, it's positive and odd, so it should be increasing overall. And this one is odd and positive, so it should be increasing overall as well. All right, which brings us to the limit notation. Boo. Again, just copy this part down. Yay. This is just something that you pull from your notes until you have it memorized. That's it. On the test, I might not even make you know it completely. I'm not going to guarantee that, so don't bet on it. Memorize it, but chances are, or I don't say chances are, there's at least a chance that you might not have to know it. I'll give it to you on the test. So this part's all memorized. The only other part that we had to pay attention to, and we know what it means, this side up here, right, as x goes to infinity, positive, I wrote it reversed here, so this means as it goes to the right, what's happening? It goes, this is the right side, right? This is the left side, right? Right goes up, positive infinity. That's what you'd write. And this one says as x goes to negative infinity, so that means the left, the function goes to, on the left, here's the left, it goes to negative infinity. That's it. I mean, that's all it is. So for this one, if it's negative and even, sometimes I even sketch it out a little bit, right? I know it's going to be something like that. So my arrows then being negative and even, and if you forgot, you would go up here and you say, oh, look, it's even and negative. You'd scroll back down here and you say, oh, both arrows go down. And then you're going to have to put the limit notation. So you're going to copy that fancy part down, x, as x values go to infinity, the right side, as the function, f of x, that's your function, goes to negative infinity because it's going down. And then you're going to copy that part again. X goes to, this time you're going to write negative infinity. The left side as the function goes to negative infinity because they both go down. I mean, that's it. So there's a summary of your notes. You should come in tomorrow. We're going to do a homework on this in class. Ask your questions. We'll summarize again. But there you go. Nice, short, and sweet. We'll see you in class.